93 in the book.
All right, number 93 in the book says, Earth is approximately 1.5 times 10 to the 8th kilometers from the sun. How many minutes does it take light to travel from the sun to Earth? The speed of light is 3.8 times 10, 3 times 10 to the 8th meters per second. We're going to make that a little bit more complicated. Not really complicated. Yeah, complicated, not more difficult necessarily. This will establish my point on, if you're doing a lot of dimensional analysis, you kind of miss the point. We're going to do dimensional analysis on this problem that you're going to be so bored with this problem by the time we're finished. I will have made my point about simple proportional relationships versus dimensional analysis, okay? So we're going to say that the sun is 93 million miles away, okay? And we know that the speed of light this is distance. And you know what that's called, by the way, in astronomy? I teach astronomy, I know, it's kind of weird, but you know what it's called? It's called an AU. This distance is 1 AU, astronomical units. The distance from the sun to the earth is called 1 AU. Capital A, capital U. It's called an astronomical unit. Weird, isn't it? Okay, now. So I want to know how long it's going to take to go from the sun to the earth. Now, what you're going to do is you're going to convert this to minutes, correct? How do you convert a distance to minutes? How do you go from a distance to time? Well, if you're doing dimensional analysis, you really don't know how you're doing it other than using a conversion factor. So we're going to do that. We're going to do this in a way where you kind of lose sight of the science. And it's just some brain-dead mathematical application. Is that a little harsh? Well, when I show you this, you'll know exactly what I mean. And we're going to use dimensional analysis that is very unnecessary, okay? So, let's do this. So we have 93 million miles, right? Now, this is the only equation I know to get to metric. This is a conversion. I'm going to say 2.54 centimeters equals 1 inch. Can you see that? 2.54 centimeters equals 1 inch. That's going to be my conversion. So I have to go from miles to inches to centimeters. I know, weird, huh? Okay. Yes, and then I'm going to go back to meters. You'll see. You ready? You ready? Okay. So, miles. We'll go from miles to feet. So, 1 mile, MI, equals 5,280 feet. Okay? When I lived in Africa, I lived at 5,286 feet. I know. The only reason I know that is now they have Google Earth. It's great. I'm not making a plug for Google Earth, but that's how I know where I lived. I could find my hut where I lived, my house I lived in, and it says the elevation. Really weird. I know. Now, so I'm going to say 1 mile, 5,280. Okay? Yes? Yes? I'm going to tell you something. I'm going to actually give away the answer to show you how little I care about this. I don't mean it like that. You'll see. 8 minutes. I mean, I know that that's the answer. It takes 8 minutes. Okay? Yes? All right, now. So now I want to go from feet to inches. 1 foot, 12 inches. Okay? Some of our brethren who are not from the United States, did you know this? How many people don't know this? Raise your hand. Okay, yeah. More than half the class. Could we do a where you're from thing quickly? I sometimes do that on my. Where are you from? UAE. UAE. Canada. America. Angola. Brazil. Where are you from? Korea. Brazil, I knew that. Jordan, Korea, America, Spain, Korea, America, Belgium, Korea, America, Where? Lebanon? Philippines. Korea. A lot of Koreans here, huh? I like that. Excellent. So most people don't know these conversions. So now we're going to convert from inches to centimeters, and I have that conversion right here. Correct? 1 inch. That's not very large, is it? Let me rewrite that. Okay? Yes? Now let's go from centimeters to meters. 1 meter, yes, is 10 squared, right? Now we've got to convert somehow from meters to minutes, okay? Well, I have a conversion because I know that 1 second equals 3 times 10 to the 8th meters. Okay, I know that. That's given me. What is this? Give me a name for that. What's the name of that conversion? No, I'm not going to tell you. Okay, fine. I'm not going to tell you. All right? I will, but not now. Okay. So I'm going to go from meters to seconds. Seconds here, meters, 3 times 10 to the 8th, 1 second. Okay? You all right with that? Okay? And then I want to go from, can I write down here? I want to go from seconds to minutes. 1 minute, 60 seconds. Okay, what's the answer? Come on, guys, do it. Multiply this out. Get your calculators out. Get them out. Shall we do an equipment check and make the quiz worth 1 billion points? If you have your calculator, you will get a graduate degree and a job that pays a minimum of $200,000 a year. If you don't have your calculator, you must go back to first grade. Understood? Excellent. Oh, I see all those calculators out. Professor Alex, do you have your calculator? You don't have one? You're getting one. Excellent. Yes. What'd you get? Did we do something wrong? 1.5? Should be 8. Unless we did something wrong. Did anybody get 8? Who? Who got 8? 93 million times this, times this, times this, divided by 100, hit divided by again, and put 3 times 10 to the 8th, divided by 60. What do you get? The tension is very high in here. What'd you get? You got 8? You got 8. Excellent. Okay? If you can't get 8, you're having a problem using a calculator, which is probably worse than not knowing proportional relationships. Because all you're doing is pressing buttons, right? So shall we press along with Mr. Darcy? Okay? If you don't know how to do this, press along with Mr. Darcy and press what I say to press and trust me. Is that clear? Excellent. All right. 9300000 times 5280 times 12 times 2.54 divided by 100 divided by 3 seconds, the little blue EE button, excuse me. Did you press the blue button? Did you press that?
Oh, no, I didn't.
Did you press times or divided by?
I put 8.
Oh, 3, then go like this. EE, 8. right?
Oh, okay.
Divided by 60 equals. Okay? You get it? Yes? Yes? You got 8, rounded. What'd you actually get?
8.31.
8.31. Okay. Got 8.3. Okay, that's right. 8.3. Okay? Now let me show you what you actually did, okay? How many people understand what you did? You just did a conversion, right? You just tacked on a bunch of factors of 1, right? Yes? Right? So, is that familiar to anybody from middle school math? Velocity or speed equals distance over time, correct? Yes? We're looking for light traveling from the sun to the earth. Do we know the velocity of the light? V. You actually say C, not V. 3 times 10 to the 8th meters per second. Correct? Do you know the distance? The distance is, what did they say in the problem? What did they say in the problem? They said 1.5. They said 1.5 times 10 to the 8th meters. Isn't that right? Correct? You get it? All right? So you know that, now you got to solve for time, right? How do you rearrange the equation to solve for time? Very simple. Very simple algebra skills. Multiply both sides by time, divide by V. You get T equals D over V, correct? Yes or no?
Yeah.
Yes? What do we want? Right? So we want, the answer is going to be in minutes, correct? Yes?
Yeah.
All right? But let's do it the way we have it. We have this in meters. I'm sorry, this is kilometers, sorry, right? Is this kilometers? Is that kilometers? Yes? Now let's use our skills and change that to meters, okay? Can we do that? A quick conversion? Why is that such a skill? Because I want you to use the metric system for what it was meant. It was meant to be a base 10 operation. So it's just moving decimal points. Clear? So if I'm going to change this to meters, what's going to happen to that exponent? How many meters are there in a kilometer? How many meters are there in a kilometer? 1,000. Give me an exponent for that. 10 to the third. I'm sorry, in exponential form. 10 to the third, right? So do you understand that if I change this number to meters, every one of those kilometers is going to be multiplied by what? 10 to the 3, correct? So what's going to happen to that exponent? That's going to equal 1.5 times 10 to the what? 10 to the what? Come on, guys, participate. I don't care if you come up with the wrong answer. It doesn't bother me. Just say something. What is it? 11. Is that what you said, Laura? And you're being shy about it. You had the right answer. Why don't you celebrate the answer? The worst thing that's going to happen is you're going to be wrong. And you know what I'm going to say? All right, we can work with that. That's okay. It's all right. You tried. That's fine. That's not a problem. Is that a terrible thing for me to say? Did I embarrass you? Okay, good. Congratulations. Extra credit, put it on my desk. Right, so that's going to be 11 meters, correct? Now I'm going to solve the problem in seconds. So who cares? Can you convert seconds to minutes very easily? Yeah. Yes or no?
Yeah.
Right, now, so what do? I just plug in. T equals 1.5 times 10 to the 11th meters over 3 times 10 to the 8th meters per second. Put that in your calculator. Yes?
Something's wrong with that.
Something's wrong? Low battery. That'll be all right. That'll fix itself. I should have plugged this in is what I should have done. I thought I did. All right? Is that switch on there? No. I'm having a technology meltdown here. It'll be all right. Okay, now. So do this in your calculator. If you have a scientific calculator, do it this way. You put in 1.1.5 second, find the little blue EE, press that, and then put in 1.1. Right, Zayed? Divided by 3 second EE 8, right? Equals. What do you get? What do you get? What do you get? 500? 500 seconds. Yes or no? Is that what you get?
Yes.
Okay. So what is 500 divided by 60? No big deal, right? How many 60s are in that 500? Do it. Come on, do it. Do it now. 8.31. It's the same thing? Oh my God. We've discovered something. You don't have to do all of that nonsense, do you? Right? What does Mr. Darcy think of dimensional analysis? Not much. DA stands for something else and I can't say it in class. Got it? Because why? Do you see that it's just really a motion problem in physics, isn't it? You're just applying a simple velocity equation. That's motion, isn't it? Isn't that a motion problem?
Yeah.
Velocity? Kennedy, you had me for physics last year. Isn't the problem extremely simple? It's just a motion problem with velocity. Average velocity, isn't it? Yeah, absolutely. How is it average velocity? Well, it starts at 3 times 10 to the 8th meters per second. It doesn't start at 0 from the sun. It starts at 3 times 10 to the 8th meters per second. It gets to Earth at 3 times 10 to the 8th meters per second. 3 times 10 to the 8th meters per second times 3 times 10 to the 8th meters per second divided by 2. It's going to be 3 times 10 to the 8th meters per second. That's the average velocity, and that's what we did. We put that in there, didn't we?
Yeah.
It's just a simple, very simple motion problem. Now, I have no problem doing conversions within the metric system, but that should be simple. You should be using the metric system for what it was meant to do, not these silly conversions. You move the decimal point, and you've got to get there. You've got to get there, be able to do it like this. I'll give you some worksheets, I'll give you some practice. You've got to do it like this. Not that nonsense of drawing out dimensional analysis. It's nonsense. You get it? So my point is, if you do too much dimensional analysis, what you do is you lose sight of the science. It's a very simple, basic application of physics. You understand? Good? You get it? All right, I'm going to do another problem. We still got 12 minutes, but we're done here, right? Problem finished.